All right, everybody. Here's my attempt to answer in a little bit more clearly fashion homework problem 10.72, which starts on page 603, and it deals with finding the power of a test. So here we have some information that was given in the problem. H naught was that we thought the mean was 300, and the alternative was it's less than 300. Alpha level was 0.05, sigma was 3, and the sample size was 6. And so using that test, we get a z-value of negative 1.645 is when 5% would fall below the critical value. And if we wanted to draw a picture of that, remember that we believe that it's at 300. And then down here, we're looking for what would be happen less than 1 out of 20 times. And so to calculate that, we're going to get an x bar. And in this picture, we have an x bar right underneath here. We said we're going to reject it if the sample mean, right here, x bar, is less than. And so we're imagining a confidence interval in a sense. We've taken the mean that we believe is 300. That's right here. And then we're subtracting 1.645 so that we have the correct number of standard deviations here so that we'll get 0.05 to the left. And then we do the standard error here of 3 for the standard deviation over the sample size of square root of 6. Now all of that comes out to 297.985. That's our critical value. In this test, if it's less than 297.985, we reject the null hypothesis and believe it's actually less than 300. So part A of the question, now we're on to the question. In part A, the question asks, find the power of this test against the alternative that it might be mean of 299. So how often will we accept H naught being 300 when the alternative is really 299? And you might think, well, quite often because those are so close together. Now, if we accept H naught when that's false, okay, we're committing a type 2 error there. There's a real difference right here. The mean is 299, but we're missing it. We're getting a false negative, okay? Remember, a false negative is when we have a real difference, but we don't catch it. So that's a type 2 error. So what's the probability of that happening? Well, we have to look at the specific alternative and say, what's the probability that x bar is going to be less than 297.95 if we have the mean of 299? And so with 299, notice that we are going to standardize right here, 297 minus 299, and get a z-value, negative 0.8287. And so now if we look at how often will you get a z-value below negative 0.827 and how often above? Well, if it's above negative 0.8287, if it's up here, that's in our area where we're going to accept the null hypothesis. But remember, the null hypothesis was false. So the probability that it's greater than that is 80% of the time. So the probability we'll make a type 2 error is 80% of the time. Now, if we were to do this backwards, if we were to say, what's the probability that z will be less than, and we could put equals to there, it doesn't make a difference, negative 0.8287, that's going to be 20% of the time. So 20% of the time, it will fall below this 297.989 if the true mean is 299. And that's the correct decision. So we'll make a type 2 error 80% of the time. The power then is 1 minus that 80%, or 20% of the time. We will detect, that's the key thing, that's the power of the test, we'll detect a difference of 1 unit. So it's very weak power because they're so close. It's very difficult to detect. So now we're on to part B. Part B considers how does it affect it if we look at 295 as the alternate. Could we identify a difference of 5 units versus 1 unit? So from before, we're going to use the same process. Remember that we're going to accept H naught if it's within a certain range of 300 right here. This is what we think in the null hypothesis. If it's less than 297.985 right down here, we're going to reject. Now, the alternative is, what if it's 295? Now, that's quite a distance. If we look at the curve, 2 standard deviations here almost are 297, so, or 298 because it's 0.9. So it's only a couple units to move 2 standard deviations. So a couple more, we're more than 4 standard deviations away. So what we see is, how often are we going to accept H naught? Well, now, if the mean is really 295 over here, very seldom will it be way up here into this area where we're still going to think it's 300. So the probability in this green curve, and it's 295 that it's in this accept, is what we're looking for. So the same reasoning applies. So over here we look at the probability that it's going to be less than 297.958, okay, that we're going to reject. This is the correct decision. We want to, if it's 295, we want to do the correct thing. So we come over here, we take 297, we standardize it, use the standard deviation, we get 2.415 standard deviations, or 0.08. Oh, excuse me, I'm doing the type. This is greater than, I missed that. So because it's greater than right there, we're looking for the tail. And so the probability that it's to the right of 297 or greater than was very small, 0.008, which means that 1 minus that 0.008 gives us the power of the test, 0.992. So this test is going to be right 99% of the time if the difference is 295. If the true difference is 295, it's a very, very powerful test. But if the difference is only 1 unit, it's a weak test. It only has a 20% power, or 80% of the time we're going to miss that difference. And so part C is just bringing that out. If we were to have a difference of 10 units, now we're talking about almost double the number of standard deviations. The power would be much greater than 0.992 because it's further from the mean. And so the further the mean of the alternative is from the null hypothesis, it's much, much easier to identify.